Well, hello, students of Red Bluff High School, specifically Math 2 students. Mr. Wheeler and I have been talking a lot about what we just feel like would be the most beneficial things for our students moving towards Algebra 2 next year. And we debated between a number of topics, one of which is kind of sad to let go, which is surface area and volume of three-dimensional figures. But we decided that ultimately what would be the best for you, since ultimately right now many of you education has become just a little bit different, but we just want to make sure that you're as prepared as possible for next year and that you go in feeling confident and ready. And that topic that we felt was the most significant in terms of being ready for Algebra 2 was actually studying quadratics, which we've already done before. So for the next couple of weeks, we're going to be studying quadratics. Specifically, we're going to remember how to factor, also use factoring to solve equations. We're going to spend some time talking about various versions of graphing quadratics and how that can be done both through factoring as well as using the axis of symmetry. And then we're going to go to solving equations through a variety of methods that don't lead to those nice answers that we see in the first portion of this set of activities, where you're going to actually have to use square roots and get irrational answers. So for the next few weeks, we're going to be studying quadratics because we just know that that's a really important topic moving into Algebra 2. So what we're going to do today is we're going to start by looking at some of those. So I'm launching my document camera right now. Just takes one moment. I got it up now. So here we go. Let's see how we can do with this thing. So let's remember real quick that when you factor, there's sort of a list of things to look for. Number one, when you factor, you always want to consider whether there is a greatest common factor that is involved. And sometimes we just skip this step because it's not really relevant. And you'll see that in the first number of problems that I do today. Next, if you have a is equal to 1, and remember when we say a is equal to 1, remember a quadratic is a problem that looks like ax squared plus bx plus c. So remember, if there's no number in front right here, that's implying that a is in fact the number 1. Now I say think diamond because some of you guys actually would like to do a diamond problem, but some of you actually just don't bother to do that diamond problem. You just sort of think about it. And then if a is not 1, we have two options. We can either do what some people call the modified diamond that uses an area rectangle, or we can do some guess and check. So I just have a couple of quick examples that I was going to remind you of. So the first one that I have down is pretty straightforward. Let's take a look at x squared plus 10x plus 16. Now, we talked about that guess and check method, and that is, the thinking the diamond. But in the diamond, remember, you want to think what two numbers have a product of 16 and a sum of 10. And this is one of those problems that I think most of you could come up very, very quickly. But if you don't come up with it quickly, you can start by making a series of values whose product is 16. So 1 times 16, you could have 2 times 8, or you could have 4 times 4. And of course, you're hoping to find one of these values that has a sum of 10. And of course, that was fairly easy to come up with, which was x plus 2 and x plus 8. And I want you to notice again that this is an expression, not an equation. So when we factor that problem, we're done. There's nothing more that we can do. You'll notice in this problem, nothing was negative, so it comes out reasonably quickly. Number two, if we change that story up a little bit and had x squared minus 14x plus 24, just like this problem above, I need two numbers that have that product and that sum. Notice that a is again 1, so we can just think through the numbers whose product is 24. So again, just as mentioned earlier, you do not actually have to make this list because frequently you can just look at the problem and just think about it and it's going to pop into your head. And clearly this number right here works, but you're going to notice that since that number right there is negative, that's going to mean that both of these numbers have to be negative to have that product be positive and the sum being negative. And of course, we've talked about this before, but A times B is B times A, so it doesn't matter which factor you put first, as long as you have the two appropriate factors. Now, moving into my third example, I changed something where now this number is negative, but the only way that you can have the product of two numbers being negative and their sum also being negative is if one of them is negative and one of them is positive, but in fact, the larger number has to be negative. So again, I'm not going to go ahead and make the list, but we could use 1 and 35. We could use 5 and 7, but I think everybody could kind of see very quickly that 5 and 7 would have a product of 35, and it would have a sum of -2 if the 7 was the negative. So this problem number 4 is the first one where I'm going to do the problem completely. Now, in this particular problem, number 4, you'll notice that I didn't have a leading coefficient of 1. So that could be a little bit of a harder problem, but the first thing we always do, remember, is to check for that greatest common factor. So I notice that every single one of these values is, in fact, divisible by the number 4. So by taking that greatest common factor out, life gets a little bit better. That becomes much easier. We can almost ignore these values for the moment. Think, what two numbers have a product of 15? Well, we either have 1 and 15, or we have 3 and 5. And clearly, a 5 and a 3 would work perfectly. So question number 5. This one is, I would actually, in my notes in a classroom setting, I would usually put a star next to it, indicating that it's a problem that people frequently have an issue with. Now, what's the big problem with this is when this number is negative and you say, hey, what do they have in common? Right now, pretty much people don't think they have anything in common, but ironically, what we want to think of is that they have a negative in common. So I'm going to take that negative out because really I want to think of this positive as a double negative. So I'm going to take one of those double negatives out and one of them here. And remember, if you distributed, you would get this problem back. Now, that's going to leave me with a 5 and a 1, and I'm good to go again. So, almost done. We just have 2 more examples to go. One of my favorite things, this is so fast. This is not a quadratic trinomial. All of these ones that I had above were quadratic trinomials. This is one of those special cases that you want to look for called a difference of squares, because x was squared and over here a 6 was squared. You could think of that middle term as a 0. And that just says, hey, what are two numbers whose product is -36 and whose sum is 0 because there are no x's here? And of course, I think most of you are telling me hurry up and put a +6 and -6, and we're done. Last question, very similar. It's kind of combining number 5 and number 6 together, is -5y squared plus 45. Again, if you have a leading coefficient that is negative, I advise students to take that value out. So if I factored a -5 out of here, I still have a y squared, but if I take a -5 from the 45, I'm going to be left with -9, which is again a nice, simple difference of squares, which a 3 got squared and a -3 got squared. Now, I'm pretty much done with what I wanted to do with you guys right now. But what I wanted to do, one last little thing, was I wanted to look at what happens if somebody says, instead of factor, what if instead of saying factor, somebody said solve? So if instead of asking the question that was right here, somebody had x squared plus 10x plus 16 is 0, we could take the factors that we previously had and think, what number would make this thing 0? Because if I could make this piece of the problem 0, 0 times anything would be 0. And again, we've done this before, so I'm not going to take very long on it, but clearly -2 and -8 would do that. In a similar way, down here, if we were to take x squared minus 2x is 35. Now, I modified that problem just a tiny little bit, but if it's not equal to 0, we move things across the equality to make it equal to 0. Factoring is now not the question. It's a tool to help answer the question, because I want to know when is this set of factors have a product of 0, which again, that would be -5 from the left and +7 from the right. And that's pretty much the end of the story. Now, I guess in number 6, some people would look at this problem in a variety of ways. Some people would look at this problem as x plus 6, x minus 6 is 0, which would lead me to -6 and +6. Other people would take a look at this problem, and you'll see this in a video that we do later. If you move the 36 across, if you took the square root of both sides, one of the interesting things in math is if you ever take the square root of both sides, that leads us to getting a plus or minus. And so you'll see that we have exactly the same answers in both instances. That's the end of my story. So that's a little bit about factoring and solving by factoring. I hope you guys are helped by that. It gives you a little bit of a memory. We're going to do a couple more of these videos helping you out over the next little bit. I hope you have a great day. Nice to see you again. Have a good one. Bye-bye.